everyone, I am back and this is part 2 of day 14 where we're going to talk about time-locked deposit and then the main VaultManager contract. For the previous video, the explanation of the previous sections, go to part 1 of it and let's just quickly get to the implementation of it. Okay, so we're saying time-locked deposit. Great. Yeah, so we're saying that, hey, everything remains same. We have to import the base deposit box.sol. Here we have to make it as time logged deposit box is base deposit, right? And then we're just trying to go a little, premium with this one, a little bit of more implementation than the original. So just like the basic deposit box and premium deposit box, we're importing the shared base logic from base deposit box, which is owner tracking, secret storage, deposit time, blah, blah, blah. And this time we would just be implementing a little bit of time lock facility. So we're saying, hey, as state variables, you want uint 256 private unlock time, okay? And then we're saying, hey, this variable stores the timestamp. When the secret becomes accessible, it's private, meaning no one can access it directly, but we'll expose it via a getter function. Now we'll quickly write the constructor for this one because we want to do something during the deployment, which is uint 256 lock duration. Okay, so when the contract is deployed, this log duration will be set and we'll set, hey, unblock time is block.timestamp plus log duration, correct? So it will take a number during deployment in log duration in seconds, and it adds the duration to the current timestamp block.timestamp and sets that as an unlock time. So example, if you pass 3600, that would be 1 hour. The secret will stay logged for 1 hour from the deployment. And this makes the contract very flexible. You can lock secrets for minutes, hours, days, or years. And now that we've written the constructor, we will go to the modifier, which says time unlock. So there might be some functions which will only work after the secret has unlocked. So we'll check the required condition where block.timestamp is greater than equals to unlock time. If yes, great. Or otherwise we say, hey, box is still logged. Okay, great. So then there's an underscore and yeah, that's the modifier check. What is the problem? Should we marked as abstract? Like really? Did we like mark this one as abstract? No, I don't think it was required, right? Because time law. Okay, let's see what is the problem, but yeah, we'll try implementing. Maybe it's missing some implementation right now, and that is why it shows like that. Okay, so now that we've written this, we have to quickly go and implement the function get type. I'll just quickly copy it and we say, hey, function get box type, external pure override. Again, no repetition on these functions. Again, now we'll also write a function called get secret. So in premium deposit box, okay, we did not write. We wrote it in base deposit box, right? Get secret. Yeah. So that was the return secret thing, right? So we're saying, we want to write a function get secret and it's the same that's going to be, but this will be restricted as not just the only owner, but also as time unlocked. That is why we have to tweak in the logic a little bit here, and we'll return it using the super keyword. Now we've actually seen it before that when you're inheriting it and you want to just bring in that function, you can just use the super keyword from the parent contract. So yeah, function get secret, public view, everything remains same, override, just with only owner. There's a time logged modifier as well, which will check that, okay, this this particular function is only going to run after the unlock time has passed, and then it will call the super.getSecret. Yeah. And then now that we've gotten the secret, we're saying, hey, maybe I just also want to check, like write a cute little function to get an idea of getting the unlock time, right? Because I might have set it and I don't have the patience to wait or do the counting. So I just want to quickly look at it and say how much time is left, right? So we're saying, oh, that should be external, view returns UN256. Now we've implemented something similarly yesterday as well. When we were looking at day 13 and we were doing the pre-sale. So we had certain seconds left before the sale was about to finish, and that is the exact time in which we have to buy the tokens and do the transactions, except the transfers. So that is, we also implemented a function that will show us the report remaining time, right? So this is a simple getter function that tells you the exact time stamp when the box becomes unlockable, which is good for, again, front ends and display purposes, etc. Now, this is for the unlock time. Now, I also want to get something as remaining lock time. So again, I will just quickly write it, which says function get remaining log time. Now, this is a very simple calculation, right? You just have to check for what is the block stamp time and what is the unlock time and just, subtract it. So we're saying, hey, returns a UN256. And then we say, okay, if block dot timestamp is greater than equals to unlock time, then you've already surpassed it and it's already unlocked. Otherwise, you have to say return unlock time minus block dot timestamp. Very simple calculation again. That's it. Like, that's the entire TimeLockedDeposit.sol. You've seen that we're just trying to put in that how we're bringing in interfaces, how we're making an abstract contract, how are we implementing the features of it into other contracts. And then you compile it and deploy it. We close this one and then there's a log duration. So I say 300 seconds from now and transact it and it goes through and voila, you can see all of this. Okay. So great for countdowns, timers, visualizing progress and all of this. Now is the time where we implement the main contract, which is the VaultManager, which is our deposit box dashboard. This contract will act like the control center for users to create, name, manage, and interact with their deposit boxes. And you should think of it as your Vault app backend. So it lets user create different types of boxes. It keeps track of which user owns which boxes. It enforces ownership rules. It provides helper functions for naming and retrieving box info, and we're going to import a lot of things. Everything that we have written as of now will be imported into this. Okay, so let's just get going. Get your glass of water, also your cup of coffee, and put your brain to, if you want a break, it's fine, but we've just started this one, so I don't think you should need a break. But if you're watching this in continuation, you can take a 5 minutes break, go for a walk, take a sip of coffee again. Although it's 12 a.m. almost, but still. Yeah. So these are all the imports that we're doing. We're saying, hey, you need to import interface deposit box, basic, premium, time locked. The base one is not required because, again, it's abstract. Everyone else is using that, so it's anyway there. So iDepositBox is the interface that we've used to interact with all type of boxes, and other three are concrete implementation, actual deployable contract. Okay, and again, why are we using this interface is because it lets us treat every box the same way, no matter what is its specific type or tier. All deposit boxes follow the same rules: get, owner, store, secret, whatever. Okay, so we don't care which kind they are. We call those shared functions anyway, right? And let's just get started with the state variables. Yeah, I mean, come on, that's the usual one. Okay, so we're saying contract vault manager. Okay, and let's think of what is it. Do we need a variable? At this moment, I cannot really think of any variable. All I can think of is a mapping where a user's address is mapped to all the deposit boxes they own as contract addresses, and maybe a mapping of the address to a string where users assign custom names to each of their boxes stored, per box of address, right? So we say mapping address, private user deposit boxes. Okay. And then another mapping of string, right? So we're saying, hey, there should be a mapping with address and a string. And we're saying private box names. Very predictable variable names again. Now, yeah, so we've talked about it, and now that we cannot think of any state variables and we've done mapping, we'll think of an event. So what kind of event are we looking at? Maybe box created, right? Like emits every time a user creates a new box, because a person can have multiple boxes, or maybe every time a user gives a nickname to their box, like depending on what kind of level of secret that they want to keep in the boxes, right? So we're saying, hey, box created, and we're saying address, indexed, owner, and we're saying address, indexed, box, address, right? And then we are also saying maybe box type, right? We're saying string, box, type. Okay, great. Then the other one would be box name, right? So every time somebody puts a box name, we're saying, hey, address, indexed, box address, like which is the box that they have named, and then string name. Great. Not great. Right again. Okay. Yeah. Okay. Now let's just go about creating a basic box. Again, we will use the deployment of a new contract from this contract, and then you'll see a few stuff, right? Like, let's just get started. I'm very excited. Create basic box. Okay. Box. And we're saying, okay, external, and it should return an address. Why? Because we're creating a box here, right? And yeah, okay. So there is basic deposit box contract, right? And we're using this format where we're saying, hey, creating an object here, deposit box equals to, and then we're using the new keyword to deploy a new basic deposit box contract and calling that particular function. And this line will deploy a new basic deposit box contract and store its address in the variable box. Okay. Now what we'll do is that there is user deposit boxes, which is a mapping. So I take message dot sender, and then I say dot push, and what? Address. We'll change it as the box, right? So adds the new box to the list of boxes owned by the sender. Very simple. And now the emit box created function should work. The owner is who? Message dot sender. The address box, and then type is basic. Okay. And yeah. And we have to return what? We have to return the address of the box. That is our entire motive here. So we're saying return address box. Okay. So now you know how to create another or deploy a new contract from inside a contract, right? So this is how users mint a new digital vault box for themselves. Okay. So this was for basic. Okay. Similarly would be for premium. So what I'll do is just copy this. Okay. And paste it. And then I'll say, okay, this basic should be premium. Again, it will return an address and this entire thing would be again premium. I cannot do command and replace because again, I can, I'll have to go through which ones are basic. So I'll just normally do it. And then we're saying user deposit box as message.sender, push address box, emit box created, message.sender, address of the box, and then make it premium because we're using, right? And return the address of the box. So again, this function lets a user create a new premium deposit box, a special kind of deposit box that supports extra data through the set metadata function. And there's nothing more that we're doing. Once it's calling that particular, contract, creating it, there's already some implementation out there, right? So once you've created a new contract, behind the scene, what it would do is inherit from the base deposit box. So it gets ownership, secret storage, deposit time, etc. Adds a new state variable called metadata and functions to update and retrieve it because that is what we implemented in premium deposit box. And when this line runs and the contract is deployed on chain, the user who called create a premium box becomes the owner of the box, thanks to again the base deposit box constructor here, right? And then you're converting the contract to its address using address parenthesis box. And then you're adding that address to the user deposit box's mapping for the user who created it. So one person can have it all, basic, premium, time bound, whatsoever. If you have not put a condition, if you want someone to have limited, then you can put such conditions. And this ensures that when the user wants to retrieve all their boxes later, this one will show up, right? Because all of it is going in one mapping mapped to the particular user's address. And then you're emitting an event for the front end. The box created event talks about the user who created the box, the address of the new contract, the string premium. So UIs know what kind of box is it. And then there's a return function, right? Like, hey, return the newly created box address. So the front end or calling code can interact with it immediately. Yeah, that's the entire thing. Right? Now, what we will do is that we will create a function called create time locked box, where we're saying that we want a function that allows user to create a time locked deposit box, a smart contract that behaves just like a basic box, but with just one crucial twist, which is the secret stored inside cannot be accessed until a certain amount of time has passed. So we'll quickly write it. Function create time locked box, and then as parameter we will pass event.6 log duration, and we say, hey, let's just get talking, right? So the function takes in a number, log duration, which represents how many seconds the box should be logged for. And yeah, whatever time you're putting, you have to look into the minutes of it. And then you're saying, hey, why is it useful? So if you're doing time capsules, if you are, revealing some messages which you want at a certain time, like a Happy New Year message when the certain time is reached, or happy birthday or whatsoever, or future gifts or commitments. So that is the case. Okay. Now, this line is correct. Time logged deposit box is equals to new time logged deposit box. Again, this will have a parameter. That is the only thing that we're doing different. Again, this is deploying a new contract using the time logged deposit box. Everything remains the same. We're saying that inside the time locked deposit box constructor, this log duration is added to the current, block timestamp and log duration. And we just want to, quickly create it and then go about what we did with the previous ones, that user deposit box is message.sender.push address box, and then emit box created message.sender address box time logged return address. Oh, no, that's just deleted. And we have to, we do not right here, AI, missing some parts of it. So we're saying external returns address, right? That is what we wanted. So we're saying return address of the box. So now you know why we have added a parameter here and why did we not add a parameter here, because in the constructor of the previous ones, we were not really passing any parameter, but in this one, we were passing the log duration. So yeah, that is why we had to give it, and that's it, right? Now, once you've created all these different kind of, time logged deposit or premium box and all of this, we might also just want to go with naming these boxes, right? Because that is also one of the events that we created and we want to play around a little bit. So we are saying, hey, I have a lot of time. Let me just write another function that says name box, right? This is where we get to trigger the other event. So we're saying address, box address, string memory name. Again, this could be called data. And then we're saying, let's close the parenthesis here and this should be here. And we're saying external and we don't want to return anything. And what is it? So we're going to first cast the generic address into the interface, for which we will write this line says I deposit box box equals to I deposit box address, right? So this lets us call the get owner on the box without knowing what type is it, because we're not looking at type here anyway. And then we check for a condition that require box dot, get box dot get owner if that is equals to message dot sender, great. Otherwise, we'll say, hey, not the box. No. Okay. Again, good error message to identify. So this ensures that a rightful person or rightful owner can rename the box. So firstly, we save the new name and then, emit an event about it. Okay. So we're saying, okay, now that we've checked the condition, we say box names. What was the keyword again? Sorry. Yeah, this was it. Box names, and then take the box address. Okay. And then take it as name. Okay. Give the name to it. And then we're saying emit. Yeah. Box named, and we're passing box address and name, right? That's it. That's the entire function, right? Now, we also want to talk about storing a secret in this one. So we're saying, hey, now we have done that. Let's just go about storing a secret, right? We've not done that here. So I say function store secret. And we're saying address, box address, and then not a uint, but instead a string called data secret, making it external. Okay. And we're saying, okay, again, the same thing. I deposit box equals to I deposit box address, checking if box.getOwner is the message to sender. If not, then you say not the box owner, and then we say box.store secret. So everything is same in terms of the ownership pattern. And then we are calling the store secret function from the interface, which is implemented in each box type. And no event is emitted here because the box itself will emit one, which is secret stored. And we've implemented it previously, right? So I think we implemented it in the base deposit box. So you don't have to worry about it. Okay. Now there's something called as transfer ownership that we're going to talk about. And yeah, I mean, that's like if you want to hand over a vault to someone else, this one's going to be a long function. So we're saying function transfer box ownership. You know what we're going to do here. I mean, it's long because, again, box address, and then we're saying, hey, who's the new owner, right? Saying new owner, and then we're saying external. Okay, great. So we'll call the same thing again. iDepositBox is equals to depositbox addresses. Check the same thing. Box.getOwner, message.sender, not the box owner. And then, what is this? What is this that they've done? Okay, now that we have done this, right, because we're looking at transferring ownership, right, so we have to make sure that the VaultManager updates its own records to reflect this change, right? So once we've taken the box address, which is just a regular address on the blockchain, and cast it to iDepositBox interface, now we can call functions like get owner, transfer ownership on it. So because we've told Solidity, hey, trust me, this contract implements the iDepositBox interface, and next we'll verify the person calling this function is actually the current owner. If they're not the owner, the function will revert. I promise. No unauthorized handoffs happening here, right? And then we're saying box dot transfer ownership, and then we're saying new owner. Okay, so this tells the box contract itself to update its internal owner state, and this is important. This actual box owns the data and logic. VaultManager doesn't control it. So these steps ensure the box updates its own permissions. Right now, you also have to update the VaultManager's mapping, where you're saying after changing the ownership inside the box contract, we now have to make sure that the VaultManager's user deposit boxes mapping reflects that too. If we don't update this list, our system will show the wrong owner in the front or using the APIs, right? So we will grab the sender list of boxes. We loop through to find that one that is being transferred. So for that, we'll have to run like an entire loop where we're saying there's a list of address. We're storing it on the blockchain, storage, right? And then we say boxes. And then we go about user deposit boxes, message.sender. So we'll search for that particular one. And then we say, hey, for uint I equals to 0. You don't need a 256 here. And you say I should be less than boxes.length. Again, we've talked about it, that how do you calculate length of the list here, and then go about it. And you say, okay, boxes at this particular one, right, is equals to boxes and boxes.length -1, and then you do a pop. So boxes.pop, as of now, we've only been using push, and then we break, right? So we're saying we loop through to find that once that being transferred, once we find it, we swap it with the last item in the array, and then call .pop to remove the last item. That is why we've done the swapping, right? I with the length -1, right? This is a classic Solidity trick to remove an item from an array without leaving gaps, because Solidity arrays don't support .remove in this particular index. Okay, and now that we've done this, right, we're saying user deposit box says new owner. Okay, new owner dot push, and then the box address. Okay. Yeah. So we then push the box onto the new owner's personal array of boxes, effectively moving ownership within our registry. That's it. That's all that we needed to do here. Okay. So yeah, I hope that's pretty clear. If it is not, just move step by step and then, understand what we're trying to do. Now let's just implement again a very simple, cute little helper function where we want to get all the user boxes. So we say function, no, always. Function get user boxes, and we're saying address user external view returns, and we're saying we want the address, right? But then that is a list, right? And then we have to check memory for that. And we say, hey, can you just return user deposit boxes? And this particular user that we have given you, right? So this function will simply return the list of deposit boxes addresses that belongs to a specific user. Why will it matter is that every time someone creates a box via create basic box or premium or time log, the address of that newly created contract is stored in the user deposit boxes mapping. And these functions allow you to retrieve that list for any address. And how it works is that user deposit boxes for that particular user gives us the dynamic array of addresses stored for that particular user. Since it's marked as view, it's read only, so calling this would not cost any gas. It will return a full array that can be used on the front end to list out all of a user's vaults. And it's a perfect use case for creating dashboards or profile pages that list a user's deposit boxes. So similarly, we would do something for get box name. Now, if we want the custom names for, am I missing the one? Oh, no, it was here. Sorry. Yeah. So we would do the same for get box name. Again, a very cute helper function. We want to return the custom name that the owner has assigned to a particular deposit box. So we pass the address. Earlier the user could have called like name box address string to give the box a custom label, and that label is stored in the box names mapping. So it will take the box address as input. It will look up that address in the box names mapping and returns whatever string was set. If no name was given, Solidity would just return the default empty string. Again, the use case would be great for improving the UI. Instead of showing raw addresses, you can show meaningful names like main vault or dad's locker or whatever, right? Now, we'll write one more final function, which is getting any box info. And that would be it for today. So just be patient with me. Function get box info. Okay. And we're saying address. Come on. Address box address, right? And we're saying, again, this has to be an external view returns. Now, because we're looking at the entire info, it would extend to multiple lines. So we'll write it like this, where we say, hey, string, what is it? Box type, definitely. Because that is one differentiation. Then maybe I also want the owner of the box, right? Then I want uint 256 deposit time, right? And then we also want the name of the box, if any, right? So yeah, that is all the information that I need, but then how do I call it? So we're saying, because we want this to be an all-in-one helper function for getting every important piece of metadata about the box, we're saying we're saying that iDepositBox equals to particular box address We're saying that, hey, we are taking the raw box address, casting it to our deposit box interface, which will help us safely call functions like getBox type, getBox owner, and everything that we've implemented without knowing exactly which type of box it is, basic, premium, time locked. And as long as the contract implements the interface, these calls will work, right? So we'll just go about this, and then we will do a return, and return what? So again, multiple returns. So we'll say box dot, come on, get box type, comma, box dot, depending on what you have added in the previous section, get box owner, box dot get deposit. So you see what way you have written the functions, and then don't just copy it blindly because I am telling you to do it. See what is the name of the functions that you've implemented and whatsoever, and then call it accordingly. Unexpected trailing comma in a parameter list. Oh, the last one will not have comma. Come on, how can we make such mistakes? We're a pro now. Yeah, so everything else fine. TimeLockedDepositBox.sol is not found. How come? Premium deposit, time logged deposit. Oh, I actually just wrote TimeLockedDeposit.sol. Actually, I would just make it box and I will just change the name here. That is a mistake on my part. Oh. Oh shit. So now it should be fine, and similarly TimeLockedDepositBox.sol should be fine. Now is there any error? Yeah, sorry, there's a missing D. Okay, box has dot length. Great. Yeah, that's what I've written. And yeah, so everything looks good, right? So we've talked about this, why we are, box dot get box type will call the child contracts implementation, return a string like basic, premium, time logged, get owner will return the current owner, deposit time would return the block timestamp when the box was deployed, box names of box address would pull the custom name, if any, from the VaultManager's internals box names mapping. And instead of making 4 separate calls, you get everything in one, right? So if you want to build a table or a card UI that shows a full summary of each user's boxes with a single call, very useful for efficient front-end rendering, this is how you do it. Now I just compile it. Unreachable code. Why is this unreachable? Again, it's boxes dot length. We've created the boxes here. Uint I equals to 0, I is less than boxes dot length, I is plus. And we've created boxes above. So I plus plus, here it's working fine. Yeah, that's what I want to write. Why is this not reachable? Let's see if there's a warning. It's not an error. But yeah, let's just try deploy. Okay, it deployed. Okay. Now I want to say, hey, create basic. Also for this address, right? 5B3, I called create basic, also create premium. I don't want to get into create time lock, although you can do it for 300 seconds or whatsoever. Now I want to get the box info. This is already a very long video, so you can just play around the deployment. No, get box info. Second. Fine. Second. So these all are there. And then we're saying address, store secret, transfer box, but I want to just give a this is an empty string. Oh, for this user, I want to get, okay, these are the multiple boxes that you've created, right? So here I'm basically giving the wrong address where I'm saying box address, right? So if I give something like, wait, this was the create basic, right? So let me just copy this and then I want to get the info here. Yeah. Sorry, I was giving the wallet address there. That is why it was not showing me the information. Box type is basic, address owner this person, deposit time this, string name. Yeah. So I've shown you this and you can play around with the other ones, create a basic one, get box type, deposit, address, get owner. So play around with these, outputs. I have already shown you some parts of it. And yeah, that's a wrap for our vault system. We started with a very simple idea, letting users store secrets securely on chain, and ended up building a modular, extensible, and well-structured smart contract system using Solidity's most powerful concepts like interfaces, abstract contracts, inheritance, a manager contract, etc. Now, what you just built mirrors the architecture behind real-world smart contract systems. Platforms like Compound, Aave, OpenZeppelin use these same layered approach with interfaces for standardization, abstract bases for reuse, and clean modular contracts on top. So now that you not only know how inheritance works, but you've also seen how to structure larger systems that scale as your product grows. I know. It's a little bit of getting complicated day by day, but then you take your time, you have a lot of time. You'd have to step aside more than 2 hours now, start reading more, and we will see you on day 15. Till then, keep building. And please reach out to us if you have any questions. Bye, guys.